This is video number 5 for sections 6.4, 6.5, and 6.6, Overall Factoring Practice. We've come now to the end of our factoring strategy. Step 1, pull out the GCF. Step 2, count your terms so that you know which strategy to go forward with. And then step 3 is always factor completely. You don't stop in these problems if there are still more pieces that can be factored. In fact, your answer would be considered incorrect unless it is fully factored. Well, in this last video, I just want to work some mixed practice examples for you. You may want to try these yourself and then use the video as a check. Let's start here with letter A. The directions in all of these problems is simply to factor the polynomial. Step 1, pull out the GCF. When I look at these two terms, I notice between 20 and 45, I've got a 5 that I can pull out, and it looks like a single x. And then I fill in my parentheses from the first guy. It looks like I would need a 4 and a couple of more x's to get back to 20x cubed. From the second guy, I have the minus. 45 divided by 5 is 9. I did take the 1x. So that's the end of step 1, pulling out the GCF. Step 2, look at how many terms you have left. I have 2 terms in here. Well, we only have the 3 categories available to us. Let's see if this fits any of our categories. I do notice that I have a minus sign here in the middle, so that's a difference. And then I'm just wondering if these two pieces here are squares or cubes. The exponent of 2 kind of gives it away. These guys are perfect squares. Let me jot down my A and my B on the side. A is whatever you multiply by itself to get 4x squared. Well, 2x times 2x is 4x squared. B, whatever you multiply to get 9. 3 times 3 is 9. We've just discovered that this is a difference of squares. That means it's going to factor according to that A plus B, A minus B factoring pattern. The 5x remains, and then this part here breaks down further. A plus B, A minus B. I can check the binomials I just came up with, but certainly neither of these contains perfect squares or perfect cubes. And so I'm finished. Here would be the final answer. As we've said several times, these problems are so easy to check. You would simply FOIL out these two parentheses, distribute in the 5x, and make sure you get back to your original polynomial. Let's go on to example B. Same steps. First step, pull out the GCF. Let's see. The middle guy doesn't have any numbers, so I'm out of luck there. The first guy doesn't have any y's, but I do believe that we have x's everywhere. I'm limited by the last guy. The last guy only has 2 x's, but I can take those 2 out, and then I just need to think carefully about what's left. Really, it's just the same thing, except 2 x's got taken out everywhere. So 6x squared minus xy, now I only have 1x left there, and minus 2y squared. Step 2, count up the terms that are left. Well, clearly I've got 3 terms sitting in here. We have 2 methods available to us, either the reverse FOIL method or the Xbox method. I'd like to demo the Xbox method one more time, so let's do that. I'll start by making a 2 by 2 box. It's always 2 by 2. And then remember, the front guy always goes upper left. That's the F part of the FOIL. The back guy always goes lower right. That's the L part of the FOIL. The middle guy, the minus xy, that's the trickiest. I know that comes from these 2 boxes. It's going to be 2 pieces that when you add them together, you're going to get that minus xy. Well, that's where the x comes in. The x, remember, helps me to identify the 2 coefficients that go in these 2 boxes. What do I know about those 2 coefficients? Well, I know these 2 terms are going to add up to negative 1xy. So the coefficients add to negative 1. And then remember the diagonal multiplication pattern. I can see that if I multiply this way, the coefficient would be negative 12. It has to be the same thing the other way, so those two coefficients must multiply to negative 12. If I can find two numbers that multiply to negative 12 and add to negative 1, I'll be all set. Be systematic about it. 1 goes into 12 times. I don't think I can make a 1 out of that. 2 goes in 6 times. 3 goes in 4 times. Okay, as soon as I write that down, I think there's got to be some way to attach a minus sign somewhere so that those will add to a negative 1. Wouldn't it just be in front of the 4? A 3 and a negative 4 will do it. Those two numbers multiply to negative 12, but they add to negative 1. So those must have been my coefficients. Now I need to put in here more than just the coefficients. I need two terms that are going to add up to negative xy. Well, it's going to be 3xy and negative 4xy. You can check it. They add up to negative xy, and if you check the diagonal pattern, that matches as well. To finish off, pull out the GCF of that top row, just the top row, and it has to be the GCF. Looks like a 3 is in common and a single x. Then just think about multiplication. 3x times blank equals 6x squared. That would be a 2x. 2x times blank equals negative 4xy. Looks like negative 2y. Negative 2y times blank equals negative 2y squared. That would be a single y. The green pieces on the edge here are the factors of that polynomial. We're ready to write our final answer to this problem. The x squared, don't forget about that, GCF. And then the other piece broke down into 2x plus y across the top and 3x minus 2y along the left side there. This is the final answer to the factoring problem. Make sure you are practicing with these trinomials until you're getting the problems right every time. All right, let's move on to letter C. Step 1, pull out the GCF. I can see that I have a 2 in common. I also see that the lead coefficient is negative, so I need to pull that out along with the 2. So my GCF here will be negative 2. That's going to change all the signs. This leaves me with a positive x cubed and a positive 8. Now I count my terms. I've got 2 terms in here. There's those 3 categories again, right? Either difference of squares, sum of cubes, difference of cubes. Well, the only one it could possibly be is the sum of cubes. I've got this plus sitting right here in the middle. Then I just have to decide if these two edge guys are perfect cubes. The 3 here is kind of a tip-off that it's going to work, or that it's hopefully going to work. A would be, what do I multiply 3 of to get x cubed? Well, it would be x. X times x times x is x cubed. Is there something I can multiply 3 of to get 8? Absolutely. 2 times 2 times 2 is 8. This fits the sum of cubes pattern. You may want to go back and refer to the formula for factoring a sum of cubes. I really just need to write it all out and I'll be done. Don't forget the negative 2 in the front. The sum of cubes formula has a binomial followed by a trinomial. The binomial says a plus b. Great, that would be x plus 2. The trinomial starts with a squared. That means square your x. X times x is x squared. Then it says minus a times b. Well, a times b would be 2x. And then it says plus b squared. Let's see, if I square 2, I get 4. That's it. I'm done. It's a messy formula, but using it is pretty simple. You just fill in all the pieces, and I think identifying your A and B is important. One nice thing you can be sure of, when you use the sum and difference of cubes formulas, this trinomial you end up with here never keeps going. Don't feel like you have to check to see if it factors. If it was going to keep going, the formula would reflect that. All right, let's go on to letter D. As usual, I check for a GCF. This time I'm out of luck. This guy doesn't have any numbers and this guy doesn't have any x's. So then I go right to step 2, count the terms. 2 terms. Well, there's my 3 categories. I see a minus sign in the middle, so that makes me think difference. And then I'm looking to see if I have perfect squares or perfect cubes. I believe I have perfect squares here. I can jot down my A and my B. A would mean, is there something I can multiply by itself to get x to the fourth? Well, that would be x squared. X squared times x squared, think about rules of exponents, that would be x to the fourth. Is there something times itself that makes 16? Of course, it would be 4. This is, therefore, a difference of squares. So it factors according to that a plus b, a minus b factoring pattern. Tempting here to stop, but remember, you can't stop if there are pieces that can continue to factor. And one of these pieces can keep going. Now, you might be tempted to think that they both can keep going. Take a look at this first guy here. I believe I still have 2 perfect squares here. X squared is a perfect square, 4 is a perfect square. However, the middle guy is a plus. This is one of those sum of squares. We realized earlier that these guys are impossible. There's nothing I can do with that. I'll just copy it down. However, the second guy also has those 2 perfect squares, and it has a minus sign in the middle. The second guy is another example of difference of squares. In this case, the a would be an x, because x times x is x squared, and the b would be a 2, because 2 times 2 is 4. So I can continue to factor this second piece, again following that same pattern. I would get x plus 2 and x minus 2. That would be as far as I can take this one, and so here would be the final answer to the problem. Finally, let's look down here at letter E, another trinomial. I'm looking for a GCF, but I don't believe there is one. And I've got 3 terms again. Let's try that Xbox method one last time. So the x squared would go upper left, the 13 would go lower right. These 2 guys, I'm not sure yet. It's going to be 2 pieces that have to add up to that plus x in the middle. Let's fill out our x. What are the 2 things we know about these 2 coefficients? Well, whatever they are, they have to add up to positive 1, right? Because the 2 terms have to add up to 1x. And the diagonal multiplication pattern has to work out. The multiplication in this way would produce a coefficient of 13. It has to be the same way the other direction. So I'm looking for 2 numbers who multiply to 13 but add up to 1. I can start listing factors. Let's see, 1 goes into 13, 13 times. I don't think I can make a 1 out of that. And then I'm stuck. There are no other numbers that go into 13. What does that mean? It means it's impossible. I cannot find 2 numbers that multiply together to 13 but add up to 1. That means you cannot fill out this x, and it means you cannot fill out this box. What do you conclude then? You conclude that this polynomial must be prime. If you go to use the Xbox method and it is impossible, that is a tip-off that your trinomial is prime. You'll notice at the bottom here I've given you a summary of our overall factoring strategy all in one place. It's got the 3 main steps, it's got the key formulas, it's got the steps listed out for the Xbox method. So hopefully this will be helpful to you as you go through the practice and the homework problems.